Assalamualaikum. Welcome to eSafe Science. Today we are going to discuss about electronics. Electronic is the easiest lesson in grade 11. Electronic means controlling the movement of electrons according to our requirements. So, first of all, we want to understand what is electricity. Electricity means movement of electrons in a particular direction. Materials that conduct electricity are known as conductors. Now, we are going to investigate what are the secrets behind a conductor to conduct electricity. Here I have expanded a portion of the conductor. Now you can see there are free electrons in the conductor. They are moving randomly. Now I am going to on the switch. Now the electrons are moving from the negative terminal to positive terminal of the battery towards the conductor. So, the electricity flows from the positive terminal to negative terminal in the circuit. So, we can understand the direction of electricity is opposite to the direction of electron movement. Then the direction of current flow occurs the opposite to the movement of electrons. What happened to the conductivity of the conductor when the temperature increases? Now we can see the temperature increases, the atoms in the conductor vibrate. So, the vibrating atom disturbs the flow of electrons. So, the current flow decreases. So, we can conclude when the temperature increases, the conductivity of metal conductor decreases. Now, let's see semiconductors. Semiconductors are in two types. The first one, intrinsic semiconductors, extrinsic semiconductors. Now study about the intrinsic semiconductors. These intrinsic semiconductors are pure semiconductor materials such as silicon and germanium. These elements belongs to group 4 in the periodic table. Now let's see how these intrinsic semiconductors are in the lattice form. I take silicon as the first example. As silicon belongs to group 4, there are 4 electrons in the outermost cell of silicon. This is how silicon atoms are arranged in a silicon lattice. Now here we can see these electrons, outermost cell electrons are making bonds, a covalent bond. Now we can see every silicon atoms making covalent bonds with other 4 atoms around it. Here 2, 4, 6, 8. So the silicon atom gets the stable electronic configuration. Now we can't see any free electrons here. So no possibility to flow an electric current. In 0K. So, in the absolute temperature, this lattice does not conduct electricity. But when the temperature increases, what will happen? Let's see. These bonds are weak. When the temperature increases, what will happen? Now you can see here the bond is breaking. A free electron releases. And what happened to the space? There is a hole. This hole represents the positive charge. When a bond breaks, a free electron and a hole form. So, around this lattice, the number of holes and the number of free electrons are equal. So, we can say this intrinsic semiconductor is electrically neutral. We know this positive charge carrier attracts the negative charge carrier. So, this hole attracts other electron. So, electrons jump to these holes. Like this, electrons can jump to the adjacent hole. So, there is a electron flow can occur. So, there is possibility to conduct electricity. Now, let's see what happens when an external potential difference connected to this intrinsic semiconductor. Now, I have connected the positive terminal to this side and the negative terminal to this side. Now you can see what's happening. At the end of this negative terminal, electron releases, hole forms, and the free electron runs towards the hole. Then another free electron runs towards the hole at the positive terminal. Then the hole at the positive terminal disappears. And this free electron runs towards the positive terminal. So, we can say the holes are moving from the positive to negative and electrons are moving from the negative to positive. Okay. Next to that, let's see what are these extrinsic semiconductors. Extrinsic semiconductors are formed by doping the intrinsic semiconductors with group 5. We know these intrinsic semiconductors are pure lattice. All atoms are same. Now, this group 4 lattice going to mix with group 5. We can use phosphorus, arsenic or antimony to mix with this silicon lattice to make a N-type. I will explain how an N-type is formed. Arsenic atom is going to mix with this silicon. So, we can take an arsenic atom here. Arsenic belongs to group 5. So, how many electrons are there in the outermost shell? Group 5, 5 electrons. Now, we can see 1, 2, 3, 4. 1 electron left without the bond. We know Once again, I will explain. This arsenic has 5 electrons. 1, 2, 3, 4, 5. Of these 5, 4 electrons are making bonds with silicon. 1, 2, 3, 4 are with bonds. Only 1 electron left without a bond. So, we know this pure lattice is electrically neutral. Now, a negative charge is excess here. So, this become the neutral become negative. Now, this is not an intrinsic because it is mixed with. The mixing process is called doping. After the doping, this become extrinsic. Cut this. Now it is extrinsic semiconductor, electrically negative. So this type is called N-type. N-type extrinsic semiconductor. We can see this arsenic atom gives one extra electron to this lattice. So, it is donating a negative charge. So, this atom is called donor atom. This is donor atom. Okay, next to that, let's see the p-type. Intrinsic semiconductor mix with group 3 element. We can use boron, aluminium, germanium or indium to mix with. Now we can see the example when mixing boron, what happened here. We know boron is group 3, so there are 3 electrons in the outermost cell. Now this boron makes covalent bond. 3 bonds, only 3 electrons. So 3 bonds, 1, 2, 3 bonds. So in this side there is a space. This space needs an electron. An electron needs space. Electron deficiency space. So we know what charge does this space represent? Positive. So this lattice has a positive excess. So it is always trying to accept an electron from anywhere. So this boron is called acceptor atom. Acceptor atom. So now we can say this lattice represent positive charge. So this type can be explained p-type. Now we can conclude. There are 2 types of extrinsic semiconductors. We can conclude extrinsic semiconductors are in 2 types. N-type and p-type. This N-type can be formed mixing group 4 with group 5. As this group 5, we can mix phosphorus, arsenic, antimony. These group 5 atoms are called donor atoms. N-type can be formed mixing group 4 with group 5. As group 5 elements, we can use phosphorus, arsenic and antimony. These group 5 atoms are called donor atoms. We can form a p-type mixing group 4 with group 3. As group 3, we can use boron, aluminium, gallium and indium. These elements, group 3 atoms, are called acceptor atoms. Now we know N-type, P-type. Next to this, we are going to go to P-N-type. What is a p-n junction? Imagine this is a pure silicon lattice. This lattice doping, mixing with one side as to p-type, other side as to n-type. Then when this n-type and p-type meeting, there is a junction formed. It is called p-n junction. Now let's see what happened in this junction. We know there are free electrons, excess free electrons in the n side, and there are holes in the p side. So what will happen? Electrons jump to the holes. Then this electron recombine with the holes. So what will happen to the charge? Charge divided, chargeless. It becomes neutral. So it forms a charge divided area at this junction. As electrons leaving from this side, it becomes a positive charge. Holes align in the inside. And when electrons make a rich line in this p side, it creates a negative charge in the p side. A negative potential form, a positive potential form. Between these two, there is a barrier. As there are excess electrons in this line, these electrons oppose to flow of electron again and again from the inside. Now, this negative potential and the positive potential are divided by this area. So, they form a potential difference. This potential difference is called barrier potential. This area is called depletion area. Depletion region. This barrier potential difference for the silicon p-n junction is 0.7 volt. If it is a germanium lattice, it is 0.3 volt. To flow the current through this barrier in a silicon lattice, we have to supply an external voltage difference greater than 0.7. Now let us see what happens when a battery connects to this p-n junction. This battery can be connected in two ways. that is, connecting a battery is called biasing. Biasing the PN junction. This biasing can be done in two ways. Number one, forward bias. The other one, reverse bias. Now let us see the forward bias. We know there is a depletion area. In the N side there is a positive potential. In the P side there is a negative potential. Connecting the PN junction as the P side with the positive terminal of the cell and the N side with the negative terminal of the cell. So as this is the positive terminal, this is the negative terminal. Positive with P side, negative with N side. We know in this cell the negative potential is rich with electrons. So these electrons pushes these electrons in the negative side. So altogether electrons make a high potential V flow. So when the electrons flow in this side, the current flows to the opposite side. Current indicated by I. What happened to this depletion area? When these electrons in the cell pushes these electrons, depletion area become narrow. So the high negative potential overcome this barrier. So electrons flow, current also flow to the opposite direction. This type of connecting the cell is called forward biasing. Now let's see what happened. This cell is connected to the opposite side. Now I am going to connect the cell, the negative side to the positive and the positive side to the inside. Now I have connected this cell, negative potential to the P side, positive potential to the N side. What will happen? We know this positive potential attract the electrons in the inside. So what will happen? Electrons from this side move. So in this side, these holes increase this side. As electrons attracted by this positive potential, holes move to this side. At the same time, holes in this side attracted by this negative potential. This negative side also move to this side. So what will happen to this depletion area? Depletion area widen. So the barrier become bigger. Electrons cannot flow. So current also does not flow. I does not flow. This type of connecting the cell is called reversed bias. So we know When this PN junction connected forward biasly, we can make a current to flow, and in the reverse bias, the current does not flow. Okay, next to that, how we can use this PN junction? PN junction allow the current to flow in one direction. Now, we are going to using this PN junction, there is an electronic component. What is this electronic appliance? It is a diode. Diode is an electronic appliance constructed using only a PN junction. So, it is called PN junction diode. This diode can be shown in the symbol like this. We know in the PN junction, current flows from the positive terminals to negative terminal. So, in this PN junction diode, the P side positive terminal and the N side negative terminal. So, this side connected to the positive potential and this side connect to the negative potential. So, the direction of current flow can be shown like this. This way, positive to negative. The terminal connect to the positive potential. So, this terminal is known as anode. This side known as cathode. In the diode, you can see as colored ring, that is cathode. The other side is anode. Now, as this junction diode allow the protecting the electronic appliances working with DC when terminals wrongly connected. There are junction diodes constructed using the germanium arsenide. This type of PN junctions emit lights. So, these light emitting diodes are called LED. LEDs are commonly used nowadays because these LEDs emits lights with a low power. So, it is used to light the homes and streets as well as in the TV screens and the computer monitors also constructed with these LEDs. These LEDs are long life and consume a low power. So, it is economically very cheap and good. The fourth use of junction diode is solar cell. Solar cells are made up of silicon diodes. When the light indents on the junction, silicon diodes produce electricity. So, it is called solar cell. Arranging the solar cells seriously and parallelly, solar panels are constructed. These solar panels are solution for the energy crisis nowadays. It is commonly used now because when producing the electricity, these solar cells are not harming to the environment. And these solar cells are long durable. So, it is also cheap and good. Now, let's understand briefly about these uses. Rectification of AC current to DC current. Let us know what are these AC current and DC current. Current supply can be given by two ways: direct current, alternate current. Direct current is given by chemical cells. Alternate current is given by dynamos. Now let's see how the voltage variation and the direction of this current flow taking place in these two types of power sources. Okay. Here you can see the dry cell. It is a chemical cell. It is connected to the circuit with a fan and the galvanometer. Now you can observe the direction of the galvanometer and the rotation of the fan. Now the fan rotates clockwise, then the galvanometer indicates the clockwise turns. It indicates the direction of the current flow. So in this cell, the current flows from the positive to negative terminal. Here you can observe the voltage does not vary with the time, and direction also in one direction. If we change the terminals of the battery, the direction changes. Fan rotating anticlockwise, galvanometer indicates anticlockwise, current flows from the positive to negative. So, when changing the terminals of the battery, the current direction changes. But in the battery, current flows in one direction with a constant voltage is a DC current. So, we can give the DC current graph like this. Now, let us observe the alternate current. Here I have connected the dynamo. Now observe the galvanometer and the rotation of the fan. Now you can see the indicator is clockwise, anticlockwise, clockwise and anticlockwise. It vibrates as an oscillation. And the fan also does not work properly. It is also vibrating. Why? The current direction changes with the time, because inside the dynamo there is the magnet rotating inside the coil. So, when the magnet rotating, the direction of the poles also changing, so that the direction of the current also changing. So, then let's draw the graph for the alternate current. Now, we can represent the variation of the voltage and the direction through the graph. In this axis, we get the current or voltage. This axis, time. We mark the clockwise as positive, anticlockwise as negative. Now, let's observe the galvanometer in slow motion. The current, we can mark 1, 2, 0, 1, 2, 3. Okay. Now, from 0 the current increases 1, 2, 3 and reaches the maximum, then backs down 3, 2, 1, 0. Then the anticlockwise 1, 2, 3, reaching the maximum, back to 2, 1, 0. Here we have get the one oscillation graph. This type of current flow is called the alternate current. In this alternate current, direction changes with the time and the voltage variation also observed. When supplying the alternate current, fan does not work properly, we can see. So, we have to make this as the DC current. Here we are using the diode. Now here we have fixed the diode. Then the current flows only the clockwise. Then the fan works properly. So, how will be the graph? In the circuit, we are getting only one side, clockwise current. So, our graph will be changes. Here, we have get the only one side current. This type of rectification is called half wave rectification. Here we are observing a great variation of voltage. There are positions, currents dropping down to 0. In this time, current does not flow. To reduce this voltage variation, we connect a capacitor. This capacitor charges, then capacitor releases the charge. So, the capacitor supplies a small current. When the current drops down to 0 from the alternate supply, capacitor supplies the small current. You can observe that the galvanometer indicator now does not come to 0. It is coming about to 1. So, there is a current supply continuously supplied by the capacitor. So, our graph will be changed like this. So, smoothing this variation is called smoothing. This graph shows half wave rectification, smoothing. Now we want to rectify the full wave. To rectify the full wave, we use a collection of 4 diodes. It is called rectifying bridge. Okay, let's operate the rectifying bridge. Now let's see the full wave rectification. Here is the circuit. This is the bridge, rectifier bridge with 4 diodes. Now I am going to connect the dry cell, upward positive, downward negative. The current from upward shown in blue color. Observe the galvanometer clockwise, current passing from D1 and passing from P, and the galvanometer indicates clockwise and current reaches the negative. Now I am turning the poles of the rails. Now I am changing the poles of the dry cell. Here the positive is downward, current from downward in yellow color, passing D2, again it passing from P and the galvanometer indicates clockwise. Current reaches D and passing from D4, galvanometer indicate anticlockwise and the current reaches the negative. Now the battery, the dry cell changes time to time. Change the current upward and downward change. Now I am going to bring the alternate power supply, the dynamo. To indicate the alternate power supply, I have given the symbol here. Okay, let's observe. Observe the galvanometers carefully and we will draw the graph also. Okay, now the galvanometer 1 indicates clockwise and anticlockwise, but the galvanometer 2 indicates the clockwise side only. You can observe the current flow. So, we can draw the graph for this. Now the alternate current read by the galvanometer 1 represents this graph, and the rectified current from the galvanometer 2 represents that graph. This shows the full wave rectification. Now we have corrected the direction change by this bridge. Now there is another problem. We have one more problem here. The voltage variation. How to correct this voltage variation? We know. We connect the capacitor. After charging the capacitor, capacitor supplied a small current. Then when the current dropped down to 0 is avoided. Although there is a reduction in the current flow, the 0 situation is avoided. This can be shown in the graph like this. Now this is rectification with smoothing. Okay, now PN junction is over. Next, PNP junction. There are two junctions. Electronic component constructed using these two junctions are called transistors. It can be PNP or NPN. In these transistors, there are three terminals. 1, 2, 3. Here also. 3 terminals. So, transistors. These junctions can be shown as a semiconductor. Doping as P. This portion doping as N. This portion doping as again P. Doping one side highly, other side low. We know the current flow from the positive to negative. So, the current flow direction can be shown like this. The middle part is called base. One of this P end is called collector. Other end of this P is called emitter. The symbol of this type transistor is like this. Here, this is the base. This is the collector. This is the emitter. The current flow direction is indicated by the arrowhead P to N. So, outside to inside. The arrowhead. This type of transistors are called PNP. Let's see the other type of transistor. Semiconductor divided into 3 portions. Here, one end is doping as N. Other end is also doping N. Doping N type differently, different rate. The middle part doping as P type. Here also the middle part is base. This part is collector. This part is emitter. We know the direction of current flow P to N. So, the current flowing direction can be shown as. This type of transistors can be shown in the symbol like this. Base, collector, emitter. Now, the direction of current flow inside to outside, outward arrowhead, base to emitter. This symbol is NPN transistor. Transistor does a great role in the electronic world. Transistors have been made a revolution in the technology. Even this transistor playing a great role, the size of transistor is very small. After the invention of these transistors, the integrated circuits become smaller. We know in the history of the computer, there were computers constructed with huge buildings. Then it became into a big hall. Then it became to a room. Then it became to a box on the desktop. After that become to the laptop, then palm top, now on the fingertop. So the systems become smaller because of these integrated circuits, small, using the transistors. Okay, now let's see how these transistors are performed in the circuits. Biasing the transistor. According to grade 11, learning about the NPN transistor. So, I am going to show you how the NPN transistor should be biased. We know the current flows from the base to emitter in this transistor. So, this junction, base emitter junction, should be forwardly biased. Forwardly biased, and a small voltage should be supplied between these two. So, the voltage controlled, voltage reduced using the high resistance. This collector should be reversely biased. Forwardly biased and supply with a small voltage. Collector reversely biased with a high voltage. Okay, now let's learn about the function of this transistor. Now, the function of transistor. To supply a small voltage to the base, the volume controller. It is a variable adjustable resistance. Here's the circuit. You can see the base emitter junction is forwardly biased, and to supply a small voltage between these two junctions in the input circuit, we have connected a variable resistance to control the voltage. So, giving the high resistance, the voltage is controlled as to a small voltage. And there are two bulbs. These two bulbs are same power. and same size. In the input circuit, the bulb is L1. In the output circuit, bulb is L2. Now, there are two switches, S1, S2. Okay, now we are going to observe what happened in the input and the output when switch on S1, S2. To observe this, we have to make a table. Okay, now we are going to observe this circuit according to this table. Okay, when S1 and S2 are off, bulb L1 not lighting up. Not lighting up, no brightness. Okay, now input circuit on, output circuit off. Bulb L1 lighting up, less brightness. Output circuit not lighting up, no brightness. Okay, next input circuit off, S1 off, output circuit on, L1 not lighting up, L2 also not lighting up. Okay, the last, S1 and S2 are on. Both input circuit and the output circuit are on. Bulb L1 lighting up, brightness less. L2 lighting up, brightness high. Okay children, now from this activity we can come to the following conclusions. Number 1, there is a current flows in the output circuit when only there is a current flows in the input circuit. Even there is a voltage supplied to the output circuit, there is not a current flows in the output circuit unless there is a current flows in the input circuit. When a small current flows in the input circuit, a large current flows in the output circuit. So, a small current in the input circuit can be amplified in the output circuit. This is called the current amplification. Okay, then let's see the applications of transistors. As the transistor is a current amplifier, it can be used to amplify the audio frequency signals. Here in this circuit, this smaller signal amplified through the output circuit. In the output circuit, the speaker is connected. So, a small sound can be amplified using the transistor. Okay. Next, this transistor can be used an auto switch. Okay. Let's understand how the transistor works as an auto switch function. We know in the transistor circuits, the input circuit controls the output circuit. To control the input circuit, we control the voltage. To control the voltage, we control the resistance. So, if the resistance is depending on our requirement, our situations, according to the situation, we can change the resistance, then we can use that as auto switch function. So, we can think our two situations. So, we have to choose a resistance vary automatically. So, which type of resistance we have to choose? We know the light dependent resistance. The light dependent resistance vary the resistance according to the light index, that is LDR. This LDR means light dependent resistor. LDR vary the resistance high or low. When there is light, the resistance is low, and it is dark, the resistance is high. So, we use these situations to make auto switches in the circuits. Here is the circuit. In the input circuit, we have connected the LDR. The LDR is light dependent resistor. When the light falling on the LDR, the resistance goes down. When there is darkness, the resistance high. The voltage between these two terminals controlled by this resistor LDR. At the night, the resistance is high. So, the voltage between this LDR also high. When it is higher than 0.7, the current start to flow through the base. Then automatically the output circuit works. Then the bulbs will light up automatically. That is the auto switch function. This is the way how the transistor used as an auto switch to light up the bulb at night automatically. Next, we will see an auto switch open the gate at night when the headlight of the vehicle fallen on the gate. Okay, this is the circuit. In this circuit, now you can see the LDR is connected here. Now we are going to set the circuit according to our requirement. Now we need to indents the light on the LDR. This is set on the gate. Now the light is indenting on the gate. Then we have connected a motor to indicate the gate, and I have fixed the fan to indicate the gate. Then now you can see the light is indents on the gate. It is indents on the LDR. Is the circuit open now? No. Then now we have to adjust the variable resistance as to our requirement. Okay, when adjusting the variable resistance, now you can observe the voltage difference. Now the voltage is about 7, okay, 8. Now the circuit is open. Now our switch is ready. Okay, now we stop the indenting of light. What's happening here? The switch is off. Okay, now we fixed our variable resistance according to our requirement. We keep this resistance constantly. Okay, now let's check the auto switch, light indenting. Now you see, now imagine our light is going to indent on the gate. It means the headlight of the vehicle is going to indent on the gate. Now what's happening? The fan is rotating. It means the motor is working. So the gate opens. This is the way the auto opening gate when the headlight falling on the gate. Okay students, now we have completed the electronics for O levels. I think this video help you to do the questions in the past papers and the model papers. So you practice well when doing the questions. If you get any doubts, send your doubts through the comments. I will help you. If you understand this lesson, share all the O-level friends. Very soon we'll release the video for the Tamil medium students too. So wait and get use of that. Okay. Assalamu alaikum warahmatullahi wabarakatuh. Assalamu alaikum. Welcome to eSafe Science. Today we are going to discuss about electronics.